Okay, hi, hello everyone. Today we're talking about the animation generation collaboration by Talking Math in Public, and I want to show you how I would do one of their prompts, the first prompt, and we will try to do it together, hopefully in under an hour. Let's see how it goes. And yeah, I will be using my custom animation package for Cindy.js. I will talk about it in a second. And before we talk about anything else, let's look at the prompt we are dealing with today. So this is Talking Math in Public, animation generation collaboration, where the goal is to make an animation, but not only the animation, but also record your process of doing it. And the first prompt is create an animation that shows the link between a sine curve and a unit circle, i.e. that the y-coordinate of a point on the circle is the sine of the angle to the x-axis at that point. So we will probably want to have a circle and then the sine curve and link them together, and probably just one revolution, one period of the sine curve. And this is what we are doing today. And as I said, I'm using Cindy.js. So if you don't know Cindy.js, it is a JavaScript library. It is mostly built for interactive stuff, but I'm using it for animations and ad block. Fantastic. So yeah, it's made for interactive stuff. I'm using it for animations, so my package is a little bit on top of it. So it's not necessarily built for animations, but we will deal with that. You can find the file that I'm showing you here in a GitHub repository, which is linked down below in the description. And maybe I will clean something up before I put it there, but you can just open it and work with it. The only problem is here at the bottom. I will show it to you right away. So at the beginning, it is a normal HTML file. At the beginning, we are loading the Cindy.js file, which is also here in the folder. And at the bottom, we are importing this animation package. And for many reasons, this importing only works on a web server, so you have to start a little web server if you're using Cindy.js on its own. It just works. You open the website in a browser and it just runs. But for this animation, you need a web server, and the simplest one is basically Python, and then it's, I think, Python -m HTTP server or something like that, which is what I'm using, and this is what we are seeing here on the right. And I already have here a little bit of boilerplate code in my file. Cindy.js has an event system for various things that can happen. You can attach code to it. We are dealing with the init script today mostly, or exclusively. The init script is called once at the start of the program when the website loads. Then you have the draw script where you put everything that you want to draw on the screen. You have the mouse down event. The mouse down event is triggered when you click the mouse button, and so you can do lots of interactive stuff that way. But we're dealing with the init script today because in the background I'm doing a couple of things so that we just need this part here. And what my animation package is doing is to create so-called animation tracks. I created this package for my YouTube channel and for other things where I want to have individual movements one after the other. So we have something appears, something moves to a different place, something changes in a way, sequential movements, and this is what this is built here for, and this is what we define here in this track data. There are a lot of, again, let's make that to one to start. I have a lot of placeholders here, so we basically just need 4 or 5, I think. And the first number is always how long the movement is, and the second number, how long the pause to the next movement is. So for sequential animations, this is what makes the most sense, at least for me. And this is why I set it up this way. And the pause, we will talk about the render modes at the very end of the video or of the stream. But the pause basically is very short in this live version we're doing now, and it's a little bit longer when we export it to a video so that we can edit it in an editing software more easily. And yeah, so at the start we have one movement, 1 second, a little pause, then another movement for 1 second, a little pause, and so on. And now we have to fill this with meaning. So yeah, let's think about. Hi Eliane. Yeah, I've seen on Blue Sky and Discord that you're starting to learn how to code. Maybe not the best introduction to coding. It's a little bit of a mess what we're doing here today, but I hope you can follow along and you enjoy it. We will have to do many things by foot, as we say in German. So for the YouTube channel, I'm trying to automate a few things a little bit more. But here today, this is just the base package that I'm using. So we will have to think about a few things more than probably necessary. But I like that because then I understand it if I'm forced to think about it. So let's think about the animation. We want to have a circle and we want to have a sine wave. So we will have to have two coordinate systems. So let's start. Let's say origin left is let's start in the center of the screen and move a few units to the left, and then we have a second origin on the right. Sometimes when you see this animation, how a circle generates a sine curve, sometimes the sine curve is directly attached to the point moving around, which I always like for understanding this movement in and of itself. But it's a little bit weird if you want to translate this to a function graph, so I want to separate that. So the basic setup here is we define a few things and now we want to draw them, and drawing in my package goes into this rendering function. So let's just see what we did here. Origin left and origin right, and if we actually open the website, we will have our 2 points here drawn on the screen. You also see debug information. Let's remove that. That's not so important, I think, for this simple animation. So we have our 2 points. We will have to move that quite a bit further. 15. Too much. It's always a good idea, if you do change something in code, always change it drastically so that you see what is actually happening. So here will be our circle, and the origin for the function coordinate system is maybe here. So maybe let's leave that in the canvas center. Maybe something like that. We can change that afterwards. And the first step is we want to let's plan out the animation. Here at the end, I always add comments, and then I'm typing what this part is doing. So at the start is as a comment. At the start, let's say draw coordinate systems, and yeah, I don't want to use Copilot, thank you. Draw coordinate system and the circle. Why is this popping up? That's annoying. The second thing is, so we have the basic setup, then we want to make the points pop up. Draw points, and the last thing is probably just a revolution, like turn point. These are the 3 main movements. Generate the coordinate system, make a little point appear, and then move the point around. That should be it. Yeah, let's start with the coordinate system. We also need a scale, how large we want to have it. So let's say the scale on the left, the scale on the right is the same, right? We want to move it over there, so the scale is maybe 3. Let's see how that works out. And now we want to start by, let's say, the x-axis of the circle, or where the circle will be. So let's say, how do we want to do this? X-axis left. It should go from a little bit of overhang. So from, let's say, minus 1.2 x-axis 0 to 1.2, 0. This should be our x-axis. And Let's get rid of this, and now let's try to animate this. Animation in my package is usually done via the lerp function. Lerp is short for linear interpolation, which more or less is involved in everything you see in a computer screen in some way or another. Something is interpolated, and we will use this directly to move the endpoint of the line from, well, the left end of the x-axis to the right end, and we move that over time. So in calculation, we can do calculations which are more elaborate, but very small things I'm usually doing right in rendering. So let's see if this is somewhat reasonable. Not clear. We want to draw. Let's write it directly above it. So let's say the endpoint is, let's make two things. The start point is, what do we have? Origin left plus scale times x-axis. So this should be the first point on the x-axis moved to the correct place. And the endpoint is not the second one. We want to move it. So we lerp from the start point to the end point over time. And as time, we want to use this first animation track, this first motion. The animation package automatically creates so-called progress variables. So for the first one, it is T1. This T1 variable moves from 0 to 1, from 0% to 100% over the time that whatever this time here is, over the course of this duration. So if we do that, the endpoint moves from the start point to the actual endpoint. And if we do that start point, endpoint, if we draw that, we will see, I hope it shows up on the stream properly. It's very thin, we will change that in a minute. So we have this line. So first of all, let's make it a little bit larger. So size is maybe 10. No, that's way too much. Maybe something like this. And you see here in Cindy.js, in this scripting language, the actual input points or the input variables for what is actually needed. Here in this case, drawing a segment, you need a start point and an end point. And everything else is a so-called modifier, which uses these arrow symbols. So the size, the color, the opacity, depending on what you're doing. So this looks nice, but of course it's a little bit small. Let's make it larger. That's probably a good circle. Let's move it over a little bit. Why not? And if we change the time, so if we make the duration of this first movement longer, it takes longer. So, but let's leave it at 1 second for now. Right, and let's make it a little bit more gray. So let's define a color, white, and then we say the color of our x-axis is maybe 0.7 white, 70% white, maybe something like that. Let's make it 0.5. That's quite nice. Probably, did I have to save? Right. And now this is basically everything. And now I copy paste it a million times, and that's how I do my animations. So first of all, let's give it a little arrow. So if you say arrow is true, we get an arrowhead, and the arrowhead size, so arrow size, I don't know, is it 1 by default? It is 1 by default, right? To make it a little bit nicer to look at, I want the arrow size. Well, first of all, I want the movement itself to be a little bit more dynamic. And for that, I'm using so-called easing functions. Ease, in, out, cubic. They are used often in animation to give a certain feel to movements, and ease in out cubic is a cubic polynomial where you start slow and you end slow, and if you use that, it gives this illusion of physical movement. Right. And now the arrow size, because it pops up, I want the arrow size also to move with this here. That's probably... Oh, I always forget to save. Maybe something like that. And the last thing I want to change is the size should also increase. And I'm usually doing this with a circular easing function, which leads to it being 0 at the start, and then it, like the graph of a circle, it grows very quickly. So that leads to something like, is my screen dirty, or is there really a point? Oh, that's the arrow. That's the tip of the arrow. Let's be lazy and just say if t1 is bigger than 0, then this weird little dot should disappear, right? Because then it only is an arrow if you actually start drawing, something like that. And yeah, as I said, you can, if you like this particular style of drawing an axis, of drawing an arrow, you can wrap that up in a separate function, a separate object, or whatever you want to do. But for the basic idea of rendering stuff, I'm just copy pasting that. So let's say the y-axis. The y-axis is of course the same on the left. Let's start at the bottom. And then let's do everything with the y-axis. Now we should have 2 coordinate axes. Wonderful. Let's make it a little bit larger again. Something like that. Now we want to have the circle. Let's see. We want to have. Let's say we want to draw the circle as a stroke, as if you draw it with a pen. So we say the circle is sample circle 2 pi. So the sample circle function creates a sequence of points along a circular arc, starting from 0 degrees, going to, in this case, 2 pi. So a full, let's say 360 degree. Because that's nicer. I always try to use degrees. So we sample a circle in 360 degrees. Before that, the standard sample rate in my package is 256, so 256 points. So let's say stroke sample rate is 512. It's a little bit finer, a little bit more granular. And then we want to draw the circle. For that, I'm going into the calculation function. The idea is we want to draw, so we have a sequence of points along, so if we is that visible here? Right, you can see it. So we have 512 points, and what we want to do is we want to draw segments from one point to the other and do that like more and more. So first of all, we have to rearrange that. Why is the circle the right size? I'm very confused. It should be much smaller. Let me... Oh, that's a funny coincidence. So I forgot how sample circle works. If you pass one number to sample circle, it's not the number of degrees, it's the radius. And 360 degrees, 2 pi is accidentally the same as our scale. So we have to use the radius, right? That's how I did it. So by default, it's 360 degrees, and you have to pass the size. Right. And what we also want to do is we want to move it to the origin. So in Sine.js you have the apply function. The apply function applies something to every point in a list or every element of a list. And in this case we want just to move it origin left. And in Sine.js every function that takes a list or an array as an input has, or manipulates it in a way, has this hash mark as a generic running variable. So this hash mark means the first entry, the second entry, the third entry, and so on. And if we do that, it should be positioned properly. Let's get rid of this draw command. And now we want to find out how far we have to draw that. So let's call it circle index. Circle index. The circle index at the beginning, it should be 1. You only want to have the first segment to show, or no segment to be precise. And at the end, it should draw all segments. So we interpolate from 1 to the sample rate. And again, we do this over time. So let's make it this one. So this is now the index moving around our list of circle points, and then we are using this function called connect. And if we plug in the circle itself, it will just draw every line segment. So let's just cheekily copy the style information here. Oh, not arrow. We don't need this to be an arrow. This would be the circle itself. Yeah, it's fine. And then to limit ourselves to what we want to do, we say, well, we don't take the whole circle, we just take element 1 to our circle index. And this filters out now the first circle index many elements. And if you connect them, you get this movement. Why is this so quick? That's uncomfortably quick. Maybe just because it's loud. Okay, something is something broke. Oh yeah, a typo. Stroke sample rate. Oh, right. Stroke sample rate. Because I made a typo here, it didn't actually override the stroke sample rate. Let's go back. Let's try to. That looks much nicer, right? So this is how we could do it. Right. And now on the, I think the size of the circle is quite nice. Let's make that a little bit smaller. And then we can move it. Oh, okay, that's not. So let's say the end point of our axis should be at something like that. Right. But we can still move it over a little bit. Right. And now we do the same thing for the coordinate axis on the right. So let's say we want to have them here. Let's copy paste the origin and the scale. A little bit of order. So this is the overall scale. Then we have everything on the left. So this is left and this is right. And so the y-axis obviously has to be the same height because we want to just move it over. And the x-axis, it should start at 0, more or less. So let's say minus 0.1. And it has to go 1 full 2 pi 360 degree rotation. Oh yeah, it's very fun to see what mistakes lead to what bugs and learning how to reverse engineer it, because that works completely different in every program and in every language. So here in the console there was this error message which I didn't catch, that something wasn't clear, so it was somewhat obvious that there was a typo because I was referencing something that didn't exist. But yeah, that's always fun to learn. Yeah, we want to go to the full 2 pi rotation, so let's just make it 7. And now again, I'm very lazy, you can automate that, but I'm just copy pasting. So let's again call this is the left side and this is the right side, and then we should be able to just, so if you're using VS Code like I do, if you mark a little bit of code of text and press Control D, it will mark everything, and that's very handy to copy paste stuff. So let's see if that, right, that works right out of the box, just that the axis is too far to the right, so it's beyond our canvas and therefore the arrow head is attached wrong. So let's move the origin maybe 2 units to the left. I don't want to make it any closer, so let's scale it down just a little bit. Let's move it over by yet another. Right. I don't want to make it much smaller. Okay, and if we do, where is the x-axis? If we make it, what is 2 pi? About 6.28. So let's make that 6.5. Still too far. That's yeah. Then let's just be. Let's see how far we have to move. That's very okay. Then I will just make the canvas a little bit larger. Then I have to zoom out a little bit, but that's not a problem. And what do I want to do? I want to move the origin a little bit more. Why is that so far? That's really... I'm really surprised that that is going so far to the right. Right. Then, yeah, let's make the canvas a little bit larger. And we have to zoom out a little bit more. You can still see it. And then so if you're planning your things, your animations a little bit better, that would work a little bit better, obviously. Okay, then maybe like that. It is what it is, right? Okay, now we have our first motion. Now we want to have 2 dots appear and maybe already a dotted line between them. So let's define our moving point. Our moving point depends on an angle. Right. So how do I have to do it? doesn't really matter too much. Right. So let's say we have an angle. So this is the angle we want to use to drive the movement in the end. So we start at 0 degree and then we define our point on the circle. So our point, let's say point A, because we will have a second one. So this sits at origin left plus scale times. Now we need a point on the unit circle, and in my package you get that with ang to vec, angle to vector, and this precisely turns that into a point on unit circles. It's just sine cosine or cosine sine. And now we can draw that. Let's say give it a color. Let's make it red. What's a nice red? 0.8, 0.2, 0.3. And then we say make a dot. So fill circle, circle, what do they call it? Point A. And how large should it be? Maybe 1 unit. Let's see how it turns out. And the color is red. Way too large. Very good. 0.3. Right. Maybe that's a good size. And now we want to make this pop up in the second motion. So we will change the radius. If we do just T2, it will just appear, right? And we can make it ease, what's it called? Ease out back. That's an easing function that makes it pop because it overshoots a little bit at the end. Very, very subtle if we zoom in. That's kind of nice. It would also be nice if we had a border, probably. Let's make a little white border by just saying draw circle in white. Right, and then the size should be, let's say, 4 pixels. And again, I want this to appear, so ease out circle T2. Oh, that's way too large again. Let's make it 2. And because I'm getting annoyed having to wait for the first one to finish, let's say current, what's it called? Current track index. Let's set it to 2, then it should start at the second motion. Right, why not? That looks kind of nice. Okay, and now we have to have a where do we start? Let's start with the motion, right? What we've done with the drawing the arrows, we try to give it this physical sensation that we start slow and that we end slow to make it a little more dynamic. If we're doing this now with the point, if we let the point rotate around, I would not do it personally to make it start slow and end slow. I would make it move in a constant speed. So let's say the angle should move from 0 degrees to 360 degrees during our third motion, so T3. Let's say make it 5 seconds long, which would, so let's start at the third. Get a little bit quicker at least for the development phase. So you have constant motion around. And I think it's better to do it that way, even if it looks like not physical, because it's a mathematical movement and not a physical process of driving around a circular street or moving something actually in space. It's the abstract idea of moving around a circle in a constant speed. So I'm doing this without acceleration or deceleration. So it's mostly a style thing. So great. We want to connect it to the origin, of course. So let's just say draw origin left and point A. Oh, what's a good size? Probably 5. And yeah, let's make it red. Let's see. Then we have this here. We want to make it appear, right? So let's make it appear together with the point. Very unmotivated here. So if we go back one step in the animation, it pops up together. I think that's okay. This is very much a stylistic choice now, whether you want to draw it from the origin to the point and then let the point appear afterwards. But I think this is fine enough. And now you also want to have a second circle in between, which indicates the angle. So we take the same circle, so let's call it circle template. So this is just a circle sampled 500. Oh no, that's not. Do I want to do that? I always try to optimize things that don't need to be optimized. So let's say angle indicator. It should also be a circle, so we can copy paste that, but we will make it smaller. Let's say a fifth, so maybe scale divided by 5. And now what do we want to do? This is also now a circle, so we have another index that has to run around the circle. So indicator, index. It should do the same as here, but it should move in the third motion is where we move the point, and we do this linearly. And now we can fill that. This is a polygon, it's a list of points, and now we can fill that. We will probably want to do that. Do we want to do that behind or above the axis? Let's make it above the axis. So things here in Cindy.js are obviously rendered in the order in which you type them out, just as in every other programming environment. If you don't do anything special, it's just the things at the bottom are rendered on top. So let's say fill poly, and where's the circle? So we can do the same. I shouldn't copy paste that, but circle. So we have to have the angle indicator, and we have the indicator index. We fill it, so the size is irrelevant. The color, we make it red again, and let's make it half transparent. Let's see how that looks. Looks good. Of course, it doesn't connect to the origin at the moment. So let's say we add the origin at the end. So in Cindy.js, it's a very funny function that no one knows about. Colon, and then this closing angle attaches another point to a list. So origin left. And if we do that, we should have our little indicator. And we can do it a little bit larger. So let's say we do it 0.5, maybe something like that, right? That looks fine. What I also always like is to have the y coordinate marked concretely. So first of all, let's make a little black dot at the origin, because there are so many things overlapping there. So origin left, it should appear, maybe a little bit smaller even, it should appear together with the other stuff, and we make it black. So black is 0, 0, 0. So now we have this pivot where we can move around, and now I want to mark the y-axis. I want to do that on top of the angle indicator. So let's say here. And what we have to do is we want to draw from the origin on the left hand side to we have our point, right? We have our point, so we want to have the origin x coordinate and the point a y coordinate. And let's make it just as thick as this one here. And make it maybe, should I make it green? Let's make it green, because it's the y coordinate, so let's make a green. Let's make a green. Oh, that's not looking good. So this is very, let's say graph color. This should also be the color of the sine graph. So let's say graph color. Green is not good. Let's make it a bluish, a dark blue or a light blue. Colors. Why not? Let's use this. Let's use this color. All right, and now we want to have a point on the right hand side, which first of all also appears. So let's say, but then moves along with this thing. So the second point, what should it be? It should be moved over to the left. So we have origin right, and the scale obviously, such that everything is scaled correctly. And now the x coordinate of our point is the angle, and the y coordinate is the sine of the angle. And if we now copy paste the drawing code, what am I doing here? This is, again, let's clean this up. This is on the left hand side. So you see, if you're doing a lot of copy pasting, it becomes a mess. but it works. So let's fill our point B. It appears together with the other point, that's fine, and then oh yeah, I multiplied the origin together with this vector, which is, by the way, in Cindy.js. Cindy.js is built for linear algebra and projective geometry. So everything you do with lists that vaguely looks like vector math, it works. So in this case, I multiplied two two-dimensional arrays, two-dimensional vectors together, so it did calculate the dot product automatically. It's very handy for doing linear algebra, but we want a plus, obviously. That looks good. At least it looks correct. That's fantastic. So now what we want to do is we want to connect the points. So let's do that. Oh no, maybe I have to do this. So this is on the left again. And this is on the right. Everything is a big mess, right? But that's okay. All right, and now I want to make this connection between the points should sit between the coordinate systems and the actual points. I think that makes it look good. So we want to draw the connection here. So draw, and now it's very easy. Point A, point B, 0.3. It should also appear. What did I do? 3 pixels. Is out circ should appear together with the other points. That's the size. Let's make the color black for now. And more importantly, we want to make it dashed. So dash type 0 is just a straight line, and dash type 1 should be something like this. Let's make dash type 2. 3 is the dots. Oh, that's not. That's probably good enough, right? Oh, right, and we don't. Maybe we want to. If the point A, our red point, is on the right hand side, maybe we can extend the dashed line to go to the y axis of our circle. Then it would always be connected. So first of all, let's make that a little bit thicker. Right, so we have to go. This is the left side, so the left side of our connector is this here, and now we want to use the y-axis is the y-coordinate is this here, and the x-coordinate is the smaller one or the larger one. I think the smaller one. My PhD advisor once gave me a good tip. If you're too confused whether one of two solutions is correct while coding, just try it out. It's a 50-50 chance, so not much time left. So let's say the minimum of the point AX coordinate and the origin left X coordinate. That looks kind of nice, right? Hopefully. And what we're now missing is the graph, obviously. So let's make that below our point, but on top of the connector. To make a graph in Sine.js, or especially with my package, there are many ways. We could also sample the graph again, just like we sampled the circle, or we can just use the plot function. Let's try to use the plot function. What we're doing is we're plotting sine of x. So the plot function is a little bit weird in comparison to other Sine.js functions because it doesn't use this generic hash mark as a running variable. You actually write sine of x like you would in Desmos, for example, or in other programs. So, and if we do that, let's see what happens. We get the sine curve plotted from minus something to plus something. So first of all, let's make it a little bit larger again, right? So let's say the size is 3, probably, yeah. And the color is the graph color. Not 3, what did I use? 5? 5. Oh, because I'm just seeing it here. If you're working with Sine.js, it might be confusing at the beginning, but these sizes, so how thick a line is, for example, they are in pixels, but the size of a circle is in internal Sine.js units. So the origin is always around here, and then like a couple of pixels is one Sine.js unit. So you always have to work in 2 coordinate systems. Right. But let's move that over. So we move that over to minus origin right x plus origin right y. That's how you move functions, right? I think that's correct. And now we have to scale it. So we have to... I'm always confused. So at the end we have to scale it up. So here we have to scale it down. That's how functions work. That looks correct, right? And now we just have to say where is the start and the end of the plot. So the start is origin right x. So it starts here, and the end point, which is always very hard to remember for me. It's not end, but stop. The stop point is exactly the x coordinate of our second point. So point B x. Fantastic. That's exactly what we wanted, right? So that's basically the whole animation. Let's go to the very beginning. Oh, there is, oh, that point, yeah. Right, we get, right, so. So okay, let's try to get these. So first of all, it looks great. It looks exactly like what I wanted, at least. But let's get rid of these artifacts. So first of all, we have this little blue dot. That happens because we have our height indicator, which is, where is it? That's a mess. Which is here, which is already drawn as a 0 length thing, so a dot, right from the start. So let's make that, let's just change its size. So this is T2, then it should appear then it appears when the black dot is already present, so that doesn't really matter. We also have here very small white dots. I don't know if you can see it. We have very small white dots here because the border of our points are drawn when they still have radius 0. So we go to our draw circle, this here. But I did set it to so let's just double check if that's the culprit. So yeah, the little white dot, and if I comment that out, it's not there anymore. So it's really this line. It should work. And now my very lazy way to do this is just to say if T2 is bigger than 0. So if we actually start to draw, then do the drawing. Let's maybe save it, and now there should be a way how to do that with calculations, but sometimes if I don't know how to do it, I will just say, please only do it when you should do it. Now we also see that this this dash here weirdly pops up, I think because the size of the dashes is calculated dependent on the thickness of the line. Because where is our connector? This is our connector here. Because we make the size change, it also changes this here. So let's just say the size is fixed, but we will fade it in. So this is the alpha value. It should appear together with the points, so maybe T2. Probably not the best way to do it. But I think I'm more or less satisfied. So what we can now do is add a few tick marks on the axis. So let's do that on the right at the very least. So let's say for all. So for all is the standard for loop in Sine.js, which iterates over an array. So let's say for all 1 to, where do we want to have the tick marks? At 0.5, pi, pi, 3/4 pi. So we need 4 tick marks, 1 to 4. And then we want to draw, let's say, the offset. Do we want to make it with offset? Why not? This is the first motion. So this is ease in out cubic T1, and we want to make them how large? Maybe 1, maybe 0.7. And what we want to draw now is we want to go from the origin, or let's define that here. Let's define anchor, I think maybe is a good name. Origin right plus, now we want to go in 90-degree steps. So 90° times our index 1 to 4, our running variable. And of course that's the x coordinate, and the y coordinate is 0. And of course we have to scale everything. So this is where the tick mark should appear, and it should go a little bit above and a little bit below the axis. So we draw anchor let's make this offset into a vector. So morally we do it the other way around. We first define our anchor and then we define the offset. And the offset doesn't depend on the tick mark, so we can just move it outside. And then we want to have the anchor plus the offset and the anchor minus the offset. And then whatever we did here with the style, this should now, oh, of course we don't want them to be arrows. Right, a little bit too large. Fantastic. And then we do the same thing with on the y-axis. So this is a little bit overkill to do this as a loop if we only have two, but then it's consistent. We want to do it at -1 and 1, and now we want to have it horizontal. So the anchor is now this. This is very silly to do it this way, but okay. Oh, and the offset now is of course wrong. So we want to make that horizontal. Again, very silly. It's probably easier to copy paste that 6 times, but right. Fantastic. So we have tick marks. What you can also do is you can try to make the tick marks only appear if the drawing of the axis reached that point, but that's not usually not something I bother with, except if you have many tick marks close together, then it looks a little bit better. But right, and I mean we are sitting at almost exactly 1 hour, so I will still do a little bit more. I will draw labels to our tick marks. I think that we can do that. So let's start with our x-axis. So we draw text at our anchor point, minus offset. So it's the lower part, but then we want to go even lower. Maybe something like that. So to be fairly below. And we want to draw we want to draw 1/2 pi, pi, 3/2 pi, 2 pi. Is that in any way? I think there's not a good way to do that. So let's say X labels. Let's just make it a list. So we have 2 pi, pi, 3/2 pi, and 1/2 pi. Not elegant, but so we take X labels, and our running variable is the index, so it should just it works. So first of all, we make it align better, align mid. We make the color 0.5 white. The size is probably fine, right? But we want to make it pop up. So let's say size is, what is it? Is it 15? Is it 20? Why not? And then we make it appear together with the axis. So why is it white? What did I, okay, another typo. I still don't know why there is this weird pop in. And I know why, I think. What if we make the start delay longer? That's very weird. So again, let's be super lazy and just say, if I actually started to do this movement, then and only then draw. Why not? Right. Yeah, now we can add ones to these tick marks. Let's do that real quick. So this is the same code. Obviously, just have to do it. Let's make it right. And we just use the index itself, and then it should hopefully work. Let's make it in tech font. It should look like this, hopefully. No, that's not. That is wrong. This should now give. Right. And we move it up a little bit. Maybe that's okay. Maybe something like this, right? But I think that's now really a good point to stop. Let me quickly show you how to turn it into a video, or at least how I do it. But the animation is done, right? Does it look good? Good enough? What do you think? I think that's good enough. So to turn this into a video, let's talk about render modes real quick. The current render mode is render mode real, which just is real-time animation, what we have seen here. What's quite nice is render mode steps. Let's get rid of that here. Render mode steps allows you to step through the animation with your keyboard. So you can jump back and you can trigger every little individual movement yourself with a click of a button, which is nice. This is very good for debugging, but it's also very cool to include this version in, let's say, a blog post or a presentation you do with Reveal.js, so you can have these semi-interactive animations. But what we want to do is we want to render mode frames. If you have render mode frames and you double click on the canvas here, let's make it full size, then it will download all the frames of the animation, which are a lot. Like in this case, I think it's 5 seconds plus a little bit of buffer, so maybe 6 seconds in total. 60 frames per second are 360 individual PNGs. Chrome here usually doesn't like that too much. So let's go over to Firefox. And let's open the console. We see how it will chug along, and 486 frames. It's relatively quick for such a simple animation, but it's still 486 individual images. Fantastic. And if we go to the download folder, where's my download folder? Let's bring it over. We have 487 items because there's one hidden at the bottom. At the bottom we have FFmpeg, which is what I'm using usually to turn this into a video. If you're using an editing software like DaVinci Resolve, you can usually just drag and drop a sequence or a set of sequentially numbered images right into it, and it will automatically turn it into a video. I'm using FFmpeg. So what I'm doing is I have a terminal, and then this is just the one command I got from the internet, which renders these sequentially named. So this is the command. It takes these files which are numbered with D digits and outputs an output MP4, and the rest are encoding specifications. And now it should be a video. Alright, we didn't render a background. Alright, so the background is by default transparent. So let's quickly do that again. So let's delete that. So just to see whether it works. I always do it by myself. Fill poly, canvas poly. So canvas poly is just the four corners of the canvas. And let's make it red. Just to see whether it works. So it does work. Fantastic. So we can turn it white. And let's try the export again. Let's go back here. What do I need? I need Firefox. Let's double click again and see how it turns out. Yeah, for my YouTube channel, I'm currently working on a system where I'm using a Node.js script which automates the whole process of open a browser, click on the canvas, wait for the 1,000 images to be downloaded, then call FFmpeg. This is all wrapped up in a single command. But for the last 2 years, I've been using this process, and it's fine. So unless you're doing like a dozen of animations per day or so, it shouldn't really matter much. Right. So these look fine. These look nice. So let's render it again into a video, and then we're done. And yeah, that's the process of how I do animations in general, and in particular this talking math in public prompt, cosine, circle and sine connection. I hope you enjoyed it. I hope you learned something. Of course, I talked much more than it is necessary. So if you're forcing your way through this animation, it's much quicker, of course. But hopefully it was a little bit of insightful. And yeah, as I said, everything will be, at least a few minutes after this live stream ends, everything will be in the repository linked below in the description. And hopefully I will see you next month for the second prompt. Hopefully this event continues because I think it's very great. So yeah, maybe until April. Bye.